Hello and welcome to Science Chomp. Today we're going to be looking at the difference between voltage and current. Now this might be a slightly longer video, so just bear with me a little bit, but it's quite important now we get all of the details completely correct. So we're going to start off with a road because we're going to use an analogy. Okay, so this is a road that is a loop. At the top of the road you have a petrol station. Let's just label that petrol station. Petrol station. And along this road we've got two cars. Like that. Now what the cars do is they fill up with petrol, and they've just got enough petrol to go all the way around and back here. And imagine here there is a bridge which goes across, and there's a man standing on top of this bridge. Now the job of this man is to count the number of cars that passes every second. Okay? And in this case, because there's only two cars, the two cars pass every second. And imagine a situation where if you increase the number of cars, you increase the number of cars that go past the bridge every second. Okay? Just imagine that. And at the bottom of the road here, imagine there's an oil drum. And when the cars reach the oil drum, a person gets out of the car and he sets all of his petrol on fire, but he leaves just enough so that they can get back to the petrol station at the top. Okay? So I'll just repeat that again. Petrol station, cars fill up with petrol. They drive past this bridge. And here we've got two cars that pass the bridge, every second. When they get to here, the cars stop. The person gets out the car. He burns his petrol, but he leaves just enough to go all the way back to the starting position. Okay? Now, what has this got to do with voltage and current? Well, this is an analogy of an electrical circuit. Okay, so what we would have in an electrical circuit, instead of a petrol station, we'd have a cell. And a cell we would draw like that in a circuit, connected to the wires like so. Okay, the cars represent the current. Okay, the actual definition of current is the rate of flow of charge. That means the amount of charge per second. And that's why this person's here on the bridge. This person on the bridge is actually representing an ammeter. Okay? What an ammeter does is it measures the amount of charge passing by every second. Okay? The car represents the current and it's measured by an ammeter. Now when they get here, what happens is the petrol is being used up. So if you took a reading of the amount of petrol here and then compared it to the amount of petrol there, you'd see that there would be a petrol difference, or we can call it a PD. And I'm calling it a PD because that stands for potential difference. Okay? Now this is what a voltmeter would do. A voltmeter measures the difference in the potential energy of that from one side of a component to the other side of a component, or rather I should say device. Okay, so that's what a voltmeter does. So what is the voltage? The voltage is the petrol that drives the car. So petrol equals voltage. Now that's not a very good, I've run out of space there. That's not a very good definition in and of itself, because if they ask you in an exam, define voltage, you can't write it is the petrol that drives the car, because that, it's just an analogy. Let me just write that here, voltage. The voltage is the energy that drives the current, essentially. That's the main thing. But more often, what they're actually talking about is potential difference. And that's the real name for voltage. Physicists call it the potential difference. And if you look at energy, One of the types of energy is potential energy. And potential energy, there's a few different types. There's gravitational potential energy, there is elastic potential energy, and there's chemical energy, which can be a form of potential energy as well. Now, in this case, we've got stored electrical energy, so it's electrical potential energy. So you've got a certain amount of energy in the current here, and then less as it crosses over to the other side of the device, you see, because some of the energy is being used up, in this case, to give off light and heat, okay? So the potential difference is the difference in potential energy between 2 points of a circuit. I will write the definitions for both voltage and current in the description below, but I hope that makes a little bit of sense. Thank you for watching. Goodbye.